Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Shamimi Akwabidijani and my matrix number is B0118102444. Today I would like to do some presentation about my part, which is part A and part C. But first I will present the part A, which is about the simulation without sweep for DC circuit. Okay, for the introduction of part A, it is a DC circuit that consists of voltage source with the value of 10 volt, and this circuit has two resistors in series where R1 has a constant value of 400 ohm while R2 has a variable value such as 100, 200, 300 and 400 ohm as shown in this figure. This experiment conducted using software, so the student need to construct a circuit to find the value V in, which is here, and V out of R1 using QUCS software. After obtaining the output data from the simulation, it will be used to do a comparison with the calculation using voltage divider formula. Okay, what is the use of voltage divider formula is it divides the input voltage into the output voltage for each resistor as it is more than one resistor. So this is the formula of voltage divider, which is V out is equal to R2 over R1 plus R2 multiplied with V in, or known as V1. Software. This is the QUCS software, and first we have to construct circuit first. We go to the software. This is the software QUCS. Click the wire and then connect all the components, and then we do some labeling V in and V out, and then go to simulation. Click the simulation to simulate. We name it SPA also. Then drag the tabular. Click the V in and V out because we want to know the V in, V out input and output. This is the table result of V in and V out. As you can see that the voltage input for every resistor is the same, except the V out for 100 resistor is 2 volt. Voltage out for 200 is 3.33 volt. And then voltage out for resistor 300 ohm is 4.29 volt. And the last is 400, which is V out is equal to 5. From the calculation, we get that voltage for 100, voltage out for 100 is 2 volt. Voltage for 200 is 3.33 volt. And voltage for 300 is 4.29 volt, and voltage for 400 is 5 volt. From the figure 2, it is showing a schematic series circuit where resistor 2 is set up 100, 200, 300 and 400 ohm. In the table result from the simulation, it shows that the V in is constant with the value of 10 volt. Meanwhile, V out is decreased because electrical potential lessen will be decreased as the current through the load increases. So the higher the load, the higher the potential drop in the circuit. So it can be concluded that the value of output voltage obtained through simulation appears to be the same with the value obtained through calculation.
Let's look at part B, a simulation with parameter sweep for DC circuit. So we have to build this circuit and then observe and explain the difference between without parameter sweep and with parameter sweep. So let's look at the with parameter sweep. We build the circuit first and then we set the parameters for parameter sweep according to the given values. So we start from 0 ohms and stop at 1000 ohms, and then the step is 50. The range is 50. So like we start from 0, 50 and then plus 50 until 1000. Okay, we click OK and then we simulate the circuit. We get, this is the output. When the R out is 50, the voltage will be 1.11, and the R out is, when the R out is 100, the voltage output will be 2 volt, and so on. So let's look at without parameter sweep. When we build a circuit without parameter sweep, we have to set the R out value one by one. We have to set it one by one and simulate it one by one. Let's look at the result. We get a range of values here for with parameter sweep, and we get just one table for the without parameter sweep, and then we have to simulate it again for R out is equals to 200, and then we have to simulate it again and again. That's all. That's the difference. Thank you.
Assalamualaikum. I will continue my part, which is part C. It is about simulation without and with parameter sweep for AC circuit. Okay, what is the introduction? In this part, we will have two methods to conduct the simulation. of the experiment. The first method is to test the R1, which is here. Will be set in variable value, which we already run the simulation for each resistor. We will edit sweep parameter, and then R1 will set to R out. So by using parameter sweep, simulation are run multiple times with variable value of the desired parameters. Second method is utilize the transient simulation to test the R1 at 100, 150 and 200 ohms. So the R1, the 50 will not use in this second method, which is sweep parameter. We added sweep parameter and then we set the R1 to R out. So the first method uses AC simulation to obtain result on the table, but the second uses transient simulation to obtain the output graph. This is the circuit that we have to construct. As you can see, this is the schematic. We go to simulator and name it as PC. So we drag the tabular and click the A, and so okay, and as you can see, this is the tabular for current and voltage. Okay, I will continue with how I do the AC simulation with adding the parameter sweep. First, we go to simulation and then we drag the sweep. Then after that, we edit the properties and go to AC simulation, and this will set this to R out because the R1 will be set to R out, and then we go here 0 to 200, 1,000, 200, 200 I think. Wait. Okay, it's 1,000, 1,000, and then the number is 21. So we go here, and then we... Okay, after that it is done. We simulate the simulation, and then this is the result. And okay, I already do all the simulation for 550, 100, 550 and 200, included the when it is added with parameter sweep, and this is the value. And what I can show you is the figure 2 show the schematic of AC simulation, and AC simulation with each resistor, and when the parameter sweep added. And after that, what I can conclude that simulation with sweep and without sweep have a significant difference. A simulation without sweep need to set up the resistor value to obtain the output. Meanwhile, simulation with sweep do not need to set up the value because the simulation will run repeatedly between a predetermined range level in the parameter between 0 to 100 ohm. Okay, this is for AC simulation. So I just replace the AC with DC simulation, and then what is the difference? In the figure 3 shows that schematic using DC for R1 equal to 100 ohm represent simulation without sweep, and R1 equal to R out represent simulation with sweep. In addition, the simulation of AC and DC was done for comparing both without and with the sweep. The DC with and without sweep is based on time, which is 0 to 0.03 seconds to examine voltage drop and current. Meanwhile, AC with and without simulation is best frequency obtain the value. DC sweep uses to run simulation of various voltage value. However, AC simulation run simulation with different frequency have a constant phase of amplitude. We click to simulate, and then this is the table from previous. We go here and drag here, and then click A and time, and then V and time, and apply, and this is the result, the graph of transient simulation. Okay, this is all the simulation, which is this is 100, 150, 200, and this is R out. And figure 4 shows the schematic using transient simulation, where the output graph is shown for each resistor. R1 is set to 100, 150, 200, and R out. Basically, transient simulation analyze the response of a circuit with the respect of time, and then as shown in graph A, B, C, and D, the voltage is changed over time, and it became a non-linear portion, voltage vs time, and current a straight line. It can be concluded that the graph with and without sweep is the same from each other.
Hi, I am Iza, and I will conduct experiment part D, power measurement. So we will construct the supply voltage to 240 volt and connect with load Z. Z is resistor value of 230 ohms for A. So to simulate, to get the graph and table, we select the simulate, and we drag and drop the Cartesian, and we select the A1 to see the result for emitter. and apply and OK. And also we select the volt for voltmeter, and we get this kind of two graph. And to tabulate the table, we select the tabula and we drop and select A1 and volt 1 and apply and OK. So we get this kind of table and graph for this circuit. So the circuit is simulated from 0 until 0.02, and the data also simulate from 0 until 0.03. And we use transient simulation and set up the parameters. Start is 0, stop is 30 millisecond. We set up this because we want to get a sine wave. So the point is 31. So after we construct, we simulate and we get the two graph. First is for current and second is for voltage, and we get also tabulate also the table. And for this kind of graph, the peak current is 1.04 ampere, and the simulation, the wave is along 0.03, and SMS voltage, the wave is along 0 until 0.03. So for this peak value voltage, we can see from graph, it has 240, and also this also has 240, and it can be interpreted that I and V are in phase as both achieve their peak positive value, and zero value are at the same instance. So the phase difference between I and V is 0. After that, we move on to B. We use the same connection and we replace the resistor with C1 capacitor, and the capacitor value for this circuit is 0 mF. And we get, after we simulate the graph, we get simulate the circuit, we get two kind of graph. So for this is the current graph, and this is for voltage, and the phase between current and voltage is pi per 2 radian. Same goes to 90 degree. So the phase difference is defined as the proportion of the period difference between the peak. Same goes to the capacitor with 50 mF value. We also get the same voltage difference, same current phase difference, and also this is pi per 2. Then for part C, for C, we use same circuit connection. So we replace with inductor. So we connect the voltage to ammeter to voltmeter and inductor. So for after we simulate this graph, this circuit, we get also two kind of graph, current and voltage, and also the table. So this kind of graph also, current and voltage is also the difference between current and voltage is also is pi per 2. The current and the voltage do not peak at the same time when the inductor or capacitor are used in an AC circuit. So that's why the difference between phase difference of current and voltage are not 0. Same goes to when we replace the L1 as 1 mH, also get this this kind of graph, and also 0 mH and also 50 mH. The value for four different capacitor value has different current but have a same voltage value. So we move on to task D. We construct the circuit like this, and we must construct the capacitor is parallel with resistor. So for this task, we also use transient simulation and with same parameters, and also the voltage with same parameter, and we replace for the capacitor with 0 mF and also 50 mF. So after we construct, we simulate, we get this kind of graph that simulate for 0 until 0.03. Also this, so we get this kind of wave. The table we tabulate, and when the 0 time, the current is 1.04 and the voltage is 240. So when 0 start from 0, the current is start from 1.04 and this start from 240, and the peak value for voltage is 240, and the peak value for current is above 500. So same go to T. we use the same circuit and replace the value of capacitor 50 mF, and also it starts from 1.04 and for current, and voltage is 240. So the difference between the phase difference between the current and capacitor also pi per 2. So for task E, we use same circuit, but we replace the capacitor with inductor. So but we have 4 different value, and for 1H we get this kind of graph. So also 0 until 0.03, it start from 1.04 for current. It start when time is 0, it start 1.04 until negative 1.04. And this also, it start from 240 until negative 240. And the peak value for this graph is 0.29, 1.29, and the peak value for voltage is 240. For this phase difference, also have between current and voltage is pi per 2 radian. Same goes to when we replace the value with 1 mH, it also give a same value of phase difference. But the peak value for each circuit, each value of inductor is different. For example, the peak value for current 1 mH is 764. You can see the maximum height 764. We can see from the maximum value. So also 0 mH and 50 mH. And that's all for part B.
Let's look at part E, where I'll be explaining about delta to delta circuit. Let's look at the circuit. The delta circuit contains of 3 source, and it connects to 3 load, which is known as balanced delta to delta circuit. So the first voltage will be a voltage and degree of 0 degree, and then second voltage will be a voltage which will be similar to VAB and VCB, because if a balanced circuit, all the voltages will be same, and all the loads, value of loads will be same. So a voltage, and then the degree will be negative 120, and for here the voltage and the degree will be positive 120. So basically the voltage is the phase is 120 degrees apart. Each voltage is 120 degrees apart. So a VAB is equals to VAB, which is here. The IAB and ZAB, VAB here, and then VBC is equals to VBC here, and then the VCB is equals to VCB here. So the IAB is equals to VAB over delta impedance, and then we can calculate all the phase current using these formulas. Let's look at the simulation, where the first voltage will be 120 volt, 50 hertz and 0 degrees, and the second voltage will be 120 volt, 50 hertz and negative 20 degrees, and the third voltage will be 120 volt, 50 hertz and 120 degrees. So all 3 sources are connected to 100 ohm resistor and 200 microhenry, 200 millihenry inductor. Let's simulate this. Simulate and run this. We will get a graph. So we click on the resistor to get the current value. So let's look here. The amplitude is approximately 1.16 and 1.16 here. All the amplitude are similar. So let's look at the error log, where I've set the current maximum values here. So as I said before, the amplitude of current is 1.01545. It is similar for all three values. There are some differences, but we can approximately take that as 0.015. Okay, now let's simulate it again to get the voltage. We simulate it, and then we get the voltage here and then voltage here. So as you can see, the amplitude is 120 volt for both the voltage, and then we look at the SPICE error log. As you can see here, the amplitude is 119.926, which is approximately 120 volt. Now let's look at manual calculation here. I have represented the simulated circuit to I've drawn that here. the resistor is 100 ohm and then the inductor is 200 millihenry. The voltage is 120, this one is 0 degrees, and here is negative 120 degrees, and this one is 120 degrees. So to find the impedance, we have to calculate the imaginary value of inductor first. So it is j omega inductor value. So 2 pi 50 the 50 hertz frequency and then the 200 millihenry. So we get imaginary value of 20 pi. We substitute the 20 pi into the Z delta, which is 100 ohm resistor plus imaginary value of I 20 pi. We plus both of that and then we get the polar form of the value, and then we substitute it to find load current at each load, which is our phase current. So we get the answer 1.016, which is similar to the approximately similar to the simulated value here, which is 1.015. Same goes to the other loads, which is load 2 and then the load 3, which is 1.016 and 1.016 here. We get 0.15 here and 0.015 here. Okay, and conclude that manual calculation is approximately same as the simulation. Thank you.
So this is the part E, last part for this experiment, three-phase connection. So for my part, I will conduct to explain about YY connection. So for this experiment, we use the LTSFI software. First, we go to the LTSFI software. So this is the YY connection. So YY connection is the three-phase system by connecting 3 voltage source together with 3 load. So it is commonly known as the Y or star configuration. So it's connected between Y connection source and Y connection load. So we can simulate this kind of graph. This is the parameter that we use to get the error log. So for this circuit, we use R1, R2 and R3 as 20 ohm, and L1, L2 and L3 is 30 amp. So the value between R1, R2 and R3 is same, and also between L1, L2 and L3 is also same. So for V1, the voltage is V1, V2 and V3 same, 1 to 0, and hertz is frequency is 50 hertz. So we can simulate this kind of graph. We select the run, and first we need to get the graph of current. So we select at V1, V2 and V3. So from this graph, we can see that the waveform simulate from 0 until 100 ms. So we can see the waveform shows that the circuit are operating under balanced three-phase load. So we can conclude that the maximum amplitude for each load is same with 5.43. The maximum amplitude we can see from the graph 0 until the peak value. And also we can see from spice error log, we can see the maximum IV1 we can consider as 5.43, same goes to IV2 and IV3. So this is the graph of current for YY connection circuit. So to get the graph of voltage, we go to select the run. We select the close to the V1, V2 and V3. So we can get this kind also balanced waveform from 0 until 100 ms. So we can consider that all the voltage, all that the maximum amplitude for each voltage also have the same value with 1 to 0. We can see also from spice at error log that voltage at V1 is 119, and we can consider as 120, and also V3 until V3 is 1 to 0. So this circuit operating under balanced three-phase voltage condition. So we can get this kind of three-phase sine wave, and each voltage has the 120 phase angle difference. So this is the result for graph of voltage for YY connection, and that's all for experiment model 3, and thank you.